Welcome to Azure Virtual WAN. Welcome everyone. Today we're diving deep into Azure Virtual WAN, Microsoft's global networking fabric that's revolutionizing how enterprises connect their distributed resources. Think of Virtual WAN as your global network operating system. Instead of managing complex hub and spoke topologies manually, Virtual WAN provides a software-defined overlay that handles that complexity for you. We'll explore everything from basic concepts to advanced implementations, including real-world deployment scenarios and best practices I've learned from working with enterprise customers. Understanding the architecture. Let me show you how Virtual WAN fundamentally changes networking architecture. The traditional hub and spoke model requires you to manage VNet peerings, route tables, and gateway connectivity manually. Virtual WAN abstracts this complexity into a global network fabric. You have one Virtual WAN instance that can span multiple regions, with virtual hubs acting as regional aggregation points. What's brilliant here is the automatic hub-to-hub connectivity using Microsoft's global backbone. Traffic between regions travels on Microsoft's private fiber network, not the public internet. The any-to-any connectivity model means your branch offices, VNets, and remote users can all communicate seamlessly once connected to the fabric. Choosing the right SKU selection is critical because you can't upgrade from basic to standard. You would need to recreate everything. Let me break down the real differences. Basic SKU is really only suitable for proof of concepts or very simple branch connectivity. You get site-to-site VPN only, limited to 2 gigabits per second aggregate, and no hub-to-hub connectivity. Standard SKU is what you want for production. It unlocks ExpressRoute support, point-to-site VPN for up to 100,000 users, hub-to-hub transit, custom routing, and third-party NBA integration. In my experience, even if you start simple, you will eventually need standard features. The cost difference is minimal compared to the operational overhead of recreating your entire deployment later. Let's start with the fundamentals. Creating a resource group might seem trivial, but proper organization is crucial for large-scale deployments. I always recommend using descriptive names with environment indicators. The resource group becomes your billing and management boundary, so plan accordingly. Notice how we are adding tags right from the start. This becomes essential when you are managing hundreds of resources across multiple environments and regions. The location you choose for the resource group does not affect where your resources can be deployed. That is determined by individual resource locations. Creating the Virtual WAN instance. This is where we create the top-level Virtual WAN instance. This becomes the global container for all your hubs and connectivity resources. The key parameters here control global behavior. Setting: allow branch-to-branch traffic. To true enables any-to-any connectivity between branch offices through the hub. Similarly, allow VNet to VNet traffic. Controls whether VNets can communicate across the Virtual WAN fabric. These are global policies you can override at the hub level. The disable VPN encryption parameter should almost always be false for security. Only disable this in very specific scenarios where you are handling encryption at another layer. Deploying virtual hubs. Virtual hubs are the regional network aggregation points. Each hub operates as a fully managed network infrastructure that you don't need to maintain. Address prefix planning is crucial here. I'm using /16 networks to provide plenty of IP space. Make sure your hub address spaces don't overlap with any connected VNets. Notice we're creating hubs in different regions, East US and West Europe. This gives us global coverage with optimal latency for users in different geographic regions. The hub creation process takes about 10 to 15 minutes. During this time, Azure is provisioning virtual routers, setting up the network fabric, and integrating with Microsoft's global backbone. Understanding gateway scale units. Gateway scaling is where proper capacity planning becomes critical. Each gateway type has different performance characteristics and cost implications. For VPN gateways, each scale unit provides 500 megabits per second. But here's what's important. You also get better BGP convergence and more concurrent connections with higher scale units. Express route gateways are more powerful. Each scale unit gives you 2 gigabits per second. If you have high bandwidth requirements or multiple express route circuits, plan accordingly. Point-to-site gateways support massive scale, up to 100,000 concurrent users. This makes virtual WAN ideal for organizations with large remote workforces. Start conservative and monitor your usage. You can scale up these gateways without downtime as your requirements grow. Log deploying VPN gateways. Now we're deploying the actual VPN gateway into our hub. This is where branch offices and remote sites will connect. I'm starting with 2 scale units, which gives us 1 gigabits per second of aggregate throughput. This should handle multiple branch connections comfortably. The BGP ASN setting is important for routing. Each region should have a unique ASN to avoid conflicts. The default 65515 works fine for most scenarios. Gateway deployment takes 15 to 30 minutes. During this time, Azure is provisioning redundant gateway instances across availability zones for high availability. Once deployed, you'll create VPN site objects and connections to link your branch offices to this gateway. ExpressRoute Gateway Deployment. ExpressRoute gateways provide dedicated private connectivity to your on-premises infrastructure. This is enterprise-grade connectivity with predictable bandwidth and latency. Notice I'm using both minimum and maximum scale units. This enables automatic scaling based on demand while maintaining a baseline capacity. ExpressRoute gateways support FastPath for ultra-high performance scenarios, and you can terminate multiple ExpressRoute circuits on a single gateway. The cost here is based on the scale units you provision, so size appropriately. Monitor your bandwidth utilization to optimize costs. Point-to-site VPN gateway. This gateway handles remote user connectivity. With the shift to remote work, this has become increasingly important for organizations. The address space 172.16.0.0/16 provides IP addresses for connecting clients. Make sure this doesn't overlap with your corporate networks. You'll need to create a VPN server configuration first, which defines authentication methods, certificates, Azure AD, or Radius. One scale unit supports 10,000 concurrent users and 500 megabits per second aggregate. For larger deployments, you can scale up to 100 scale units. Virtual Hub Routing Deep Dive. This is where Virtual WAN's routing engine really shines. The default behavior provides any-to-any connectivity, but you can implement sophisticated traffic engineering. Route tables in Virtual WAN work differently from traditional networking. You have association, what routes a connection learns, and propagation, where a connection advertises its routes. The default route table handles most scenarios automatically. Custom route tables enable traffic segmentation, security policy enforcement, and compliance requirements. Labels are powerful for bulk operations. Instead of configuring each connection individually, you can propagate routes to all connections with specific labels. Custom route table configuration. Here we are creating a custom route table for DMZ traffic. This demonstrates how to implement traffic inspection through security appliances. The route we are creating directs specific traffic, 10.100.0.0/16, through Azure Firewall. This enables centralized security policy enforcement. Labels help with organization. DMZ and security labels make it easy to identify the purpose and apply bulk configurations later. The next hop can be a resource ID, like Azure Firewall, or an IP address, like an N versus A. This flexibility supports various security architectures. Connecting VNets with custom routing. Now we are associating a VNet connection with our custom route table. This determines how traffic from this VNet will be routed. The associated route table defines what routes this connection learns. The propagated route tables define where this connection advertises its routes. This VNet connection will now send its traffic through the DMZ route table, which directs it through Azure Firewall for inspection. This pattern enables zero-trust networking where all traffic is inspected before reaching its destination. This sequence shows exactly how traffic flows when using security appliances. Every packet is inspected before reaching its destination. When VNet sends traffic to VNet B, the virtual hub performs a route lookup and finds our custom route directing traffic through Azure Firewall. Third-party NBA integration. This sequence shows exactly how traffic flows when using security appliances. Every packet is inspected before reaching its destination. When VNet sends traffic to VNet B, the virtual hub performs a route lookup and finds our custom route directing traffic through Azure Firewall. The firewall applies security rules, threat intelligence, and application policies before forwarding allowed traffic. Return traffic follows the same path, ensuring stateful inspection and symmetric routing. This provides comprehensive security coverage. The latency impact is minimal, typically adding only 1 to 2 milliseconds for the additional hop through the security appliance. Third-party NBA integration. Sometimes you need capabilities beyond Azure's native security services. Virtual WAN supports integration with third-party network virtual appliances. Popular options include Palo Alto Networks, Fortinet, Checkpoint, and Cisco. These provide advanced threat detection, SSL inspection, and specialized compliance features. The architecture uses BGP peering between the NBA and virtual hub. This enables dynamic routing and automatic failover capabilities. NVAS are deployed in dedicated VNETs with multiple interfaces, external, internal, and management. This provides proper traffic segmentation and administrative access. Creating the NBA infrastructure. We are creating a dedicated VNet for our NBA deployment. Using 10.50.0.0/16 ensures no IP conflicts with existing infrastructure. The external subnet handles internet-facing traffic, while the internal subnet connects to the virtual hub. The management subnet provides administrative access. This three-subnet design is typical for enterprise NBA deployments. It provides proper traffic isolation and security boundaries. Make sure to size your subnets appropriately. NVAS often need multiple IP addresses for clustering and high availability configurations. Connecting NBA to Virtual Hub. This is where we establish the connection between our NBA VNet and the virtual hub. The static route configuration is crucial here. We're injecting a default route 0.0.0.0/0 pointing to our N versus A's internal interface. This directs all traffic through the security appliance. The Enable Internet Security parameter ensures internet-bound traffic also flows through the NBA for inspection. The next hop IP address must match your N versus A's internal interface configuration. Coordinate this with your security team during planning. Complete deployment strategy. This flowchart shows the logical deployment sequence. Each step has dependencies that must be completed before proceeding. The decision points help you customize the deployment based on your specific requirements. Not every organization needs all gateway types. Some steps can be parallelized. For example, you can create multiple hubs simultaneously, or deploy different gateway types in parallel. Plan for validation at each step. Test connectivity before moving to the next phase to avoid troubleshooting complex scenarios later. Deployment automation. Here's a complete automation script that ties everything together. This follows infrastructure as code principles for repeatable deployments. Notice how we're using variables at the top for easy customization across different environments. This script can be parameterized for dev, test, and production deployments. The echo statements provide progress indicators, crucial for long-running deployments. Gateway creation can take 30+ minutes, so user feedback is important. Add error handling between each step for production use. Check command exit codes and stop execution if any step fails. Questions and answers. Let's address some common questions I get about virtual WAN implementations. These scenarios come from real customer deployments and represent the most frequent challenges and considerations. Take your time reviewing these. They will help you avoid common pitfalls and optimize your virtual WAN deployment for success.